Hello, this is Mr. Stansbury. I'm going to take you through the notes on modeling with calculus. Okay, so we're going to take a look. Really, this is the same example as they have in the book for number 6. I just added myself a little picture over here for fun. Anyway, the cost of manufacturing the parts for X robots each day is given by C of X equals AX cubed plus BX squared plus CX plus D dollars. Okay? Where the max output for the factory each day is 200 robots. So they can't produce any more than 200 robots in a day. Fixed cost for keeping the factory running is $3,400 per day. So that's just their startup cost. The parts for the first robot each day costs $449. Okay, and the cost for manufacturing parts for 100 robots each day is $38,300. Cost for the 101st set of parts is $246. So that's to make the additional. After you make the first 100 robots, it's an extra $246 to make the next robot. Okay, so using this information, find the cost function for producing the robot parts using the derivative at 0 would be the cost of 1 minus the cost of none, and then also the derivative at 100 would be the cost at 101 minus the cost of 100. So that's the cost of the 100 and to make the 101st robot there. Okay, so we've got our cost function, and it says that it costs $3,400 a day just for keeping the factory running, basically. So that has to be our D. That's our fixed cost. Okay, so fixed cost is always be whatever that constant is, because we haven't made any robots, so we would be finding the cost of 0 would be A times 0 cubed plus B times 0 squared plus C times 0 plus D. All of these turn into 0. So our D, again, has to equal $3,400. Okay. Now, if we take the derivative of this function, so we've got C of X is A X cubed, that's not a 9, that's an A, plus B X squared plus CX plus D. If we find the derivative function, C prime of X, is going to be 3AX squared, right, plus 2bx plus c. Okay, so now using this info here, the derivative at 0 is going to be basically the cost of the first robot, because that's the cost of the first robot minus the cost of no robots. And it says right here, parts for the first robot each day cost $449. So that means that we should have that C, the derivative at 0, is going to equal $449. Okay, so that's going to be important. This is going to be important because we got to find A, B, C, and D, right? So we found D. So let's circle that and hold on to that for later. We know that the derivative at 0, $449, because that's how much it costs to make the first robot. And now also C prime at 100. That's going to be the cost of the 100th robot minus the cost of making the 101st robot. They actually tell us right here the cost of the 101st set of parts is $246. So that is going to be $246 for the 101st robot. All right. So what we can do is we can take this information here and plug it into our derivative function, which is this one. So we can say the derivative at 100 is basically, we're going to plug in 100 for all these x's, right? 3a times 100 squared plus 2 times b times 100 plus c has to equal 246, right? Okay, so we can get rid of that part there. 100 squared is 10,000, right? So that's going to be 30,000 A plus 100 times 2 is 200b plus c equals 246. Okay. Okay, I'm going to back up a little bit here, and I'm going to go back to use this piece right here again. So since we know that c, the derivative at 0, equals 449, since c, the derivative of 0 equals 449, here's our derivative function. If we were to plug in c prime of 0 equals 3a times 0 squared plus 2b times 0 plus c, and we know that that has to equal 449. So this turns into 0, this turns into 0, so that means now that c has to equal 449 as well. So now we have both c and d. With this information here, we will want to plug that in for this piece right here. So I'm going to fix that, plus 449 equals 246. So we can subtract 449 from both sides. And we will then get 30,000 A plus 200B is going to have to equal negative 203. Okay? Okay, we're going to hang on to this equation here till later. And then what we're going to do is we're going to use one more piece of info here. We know that the parts for 100 total robots each day is 38,300. So we know if we take, let's see, the cost of 100 total robots is 38,300. So we can take that and plug that back into our original cost function right here, right? And see what we get. So we get the cost of 100 is going to equal, we've got 3 times, oops, not the 3, sorry. We've got a times the x, which in this case is 100, cubed, plus b times x, which is 100 squared, plus c times x, but we now know that c is 449, so we're going to do 449 times 100, plus d, which we figured out earlier was 3,400. Okay, and now we're going to we know that this has to equal 38,300. Gosh, I keep doing that. 38,300. Okay, so we simplify this. 100 cubed is, let's see, that's going to be 1,000,000. 1,000,000 A plus 100 squared is 10,000 B plus 44,900 plus 3,400 equals 38,300. Okay, so we can take our calculator up here to help us with 44,900 plus 3,400. Oops, messed that up. 44,900 plus 3,400. Oh man, I messed it up again. Let's try this one more time. 44,900 plus 3,400 gives us 48,300. So this here is simply 48,300, which we're going to want to subtract that from both sides, right, to get rid of that from over here. And over here that leaves us with negative 10,000, and we have 1,000,000 A plus 10,000B equals negative 10,000. Okay? I'll move this up to give us a little bit more space here. So what we're going to want to do is we now actually have two equations with A's and B's equaling two different things. So we could enter this in just like it is, but look, we can divide all of these by 10,000 just to make our numbers much more manageable when we put them in. You don't have to, but it's just going to make this equation here, all those zeros go away, so we get 1,000, no, excuse me, 100. I missed one. Oh yeah, this one here. That one goes with that. All right, just went back and redid it. So that gives us our 100A plus B is going to equal -1. So now we have two different equations here. And what we can do is we can plug this into the graphing calculator to help us solve the two equations and two unknowns business. So I'll show you that here. Okay, I'm going to plug it into the PolySimult 2. You can also do this with matrices, but I just find PolySimult 2 to be a little bit nicer. So apps, if yours happens to show up on the first screen, great. If not, alpha, and then push 8 for P, and it'll go straight to all the apps that start with P, and you should be able to find it pretty quick with that. So PolySimult. Now we want to find the simultaneous equation solver. So we're going to want 2 here. And now we have two equations. Enter with two unknowns. Enter just the A's and the B's, because we now know, we already figured out what C and D have to equal. And then we're just going to simply do next. And then we're going to enter in our two different equations. So our first one, we can do 30,000A. And then it's already got plus in there. And then we got 200B. Right? And then this equals -203. Make sure you push the negative and not the subtract. Okay, and then our second equation is the one that we made a little bit nicer, so that's 100. A, 1B, oops, let's see, 100A, 1B, and -1 is our answer for that there. And we go to solve, and we get -3 e to the -4th. So normally we look at that and say, oh, that's really close to 0, which it is, but we actually want to figure out what that is because it is going to be a really small number, but if we plugged in 0, that would just get rid of our A value, and we don't want to do that. So if we get -3 e to the let's see, how did they have it written on their calculator? E to the -4. E to -4. What that means is that's -3 times 10 to the -4th. So there's our decimal. We're going to move it back 4 spots to the left. 1, 2, 3, 4. So it's going to be 0. We plug all zeros in for all those. 0, 0, 0, 3. And that's a negative as well. That's going to be what A is. And then it says that B was, I think, 0.97. -0.97. -0.97 is what our B is. Okay, so now we did all that work to find A, B, C, and D. Now that we know all this, we can find the cost for producing the parts for 150 robots each day by plugging 150 into our original equation with our new A, B, C, and D, right? So let's do that. Let's see, quit the app, right? So we're going to plug in, let's write it down first just to make sure that we're all good here. So, sorry, I'm kind of working around in circles here. I'm just looking for extra space. Let's do part B in pink here. All right. So what we're going to do now is do cost of 150 is we're going to plug in to our original formula right up here, ax cubed plus bx squared plus cx plus d. We now know that a is negative 0.97 times 150 cubed, right, plus negative 0.97. So let's turn the plus into a minus 0.97 times 150 cubed plus our C is 449 times 150, and then plus our D, which is 3,400. And then we just simply want to solve that right there. Okay, so pull that thing up, enter this all in, and hit equals, and away we go. Realize this is supposed to be our point, negative 0.0003, so let's fix that. Negative 0.0003. There, that's better. And now we can enter that all into the calculator. Okay, and also this cube here is supposed to be a square. Lots of spots to make errors, apparently. So I put that all into the calculator here. We push enter and cross our fingers that we hopefully get the right answer here. And we do 47,912.50. So it's going to cost $47,912.50 to produce 150 parts for 150 robots in a day. All right? Okay. That was one example. I realize that's a bit of a doozy here, this modeling with calculus, but we'll be able to work through it. We'll figure it out. Okay? So if you have any further questions on any of this, please feel free to ask. Thanks.